Hey guys, so this video lesson is going over the ratios and proportions study guide. Please make sure you have open this PowerPoint as we go through so you can be either checking your work or completing it with me. All right, our first slide gives us a scenario. It says you are buying video games from an online website. Each video game costs $35. Create a table that shows the cost for 0 to 4 video games. So first thing we're going to do is label our title and our X values and our Y values. So the title, I'm just going to title this video game cost. You can type it, you can write it. Whoa, that is sloppy. So I titled it video game cost, and then our X values are going to be how many video games we're buying. So just label it video games. And they want us to tell them our Y value, the cost for 0 through 4 games. So they already filled in the 0 for us. So going down our X's, it's going to be 1 game, 2 game, 3, and 4. So for each one, we have to figure out the cost as we buy more games. So 0, well, if I buy 0 video games, my price is going to be, or my cost is going to be $0. They told us in the original problem, each video game costs $35. So if I buy 1 game, that'll be $35 as my total. For 2 games, 2 ways you could do this. You could take 35 and multiply by 2, or you could just add 35 to your cost of 1 game, which was $35. So 35 times 2 gives me a total cost of $70. 35 times 3 gives me a total cost of $105. And then if I buy 4 games, my total cost would be $140. So a couple questions after we filled out our table. It says, what is the constant rate of change? So what is our K value? Well, our K is going to equal 35, right? That's our unit rate. That's our constant rate of change. And then, is this direct variation? Well, yep, it is, because I have a K value that is consistent for each of my X and Y values. So absolutely, this is direct variation. And it asks us to write an equation to represent the situation. Well, first off, remember, our equation should always be in the form y equals kx. And we found out that our K value is 35. So our equation should be y equals 35x. All right, next one. Walmart is having a sale. It costs $27 for 3 sweaters. Create a graph with numerical scales that show the cost for 0 through 5 sweaters. So I'm going to make a little table off to the side that my X values are going to be number of sweaters, and then my Y values are going to be the cost. And they asked us to find the cost of 0, 1, 2, 3, 4, and 5 sweaters, but they only told us that the cost of 3 sweaters is $27. So first thing I need to do is figure out my unit rate. Okay, so if I know that 3 sweaters is $27, I need to figure out the cost of 1 sweater. The way you do that, a couple ways you can solve a proportion. I'm just going to divide by 3. Divide by 3. So I know that the cost of 1 sweater is going to cost $9. And then I'm going to use that unit rate to fill out the rest of my table. So if I buy 0 sweaters, my cost is $0. If I buy 2, it'll be $18. If I buy 4 sweaters, well, 4 times 9 is 36. And then last but not least, if I buy 5 sweaters, my total cost would be $45. Then once I have my table, I can use that to graph my numbers. So on my x-axis, remember in our table, we called that our number of sweaters. And we went from 0 to 5. So 0, 1, 2, 3, 4, and 5. And then our y values was our cost or our money, and that went from 0 to 45. So 0, 9, 18, 27, 36. Hopefully yours is not as sloppy as mine. Can't write that small. But so there's our graph. From here we can graph our points. So 0, 0, right in that corner. 1, 9, 2, 18, 3, 27, 4, 36, and 5, 45. Should be a straight line going up. Perfect. Then they give us a few questions off to the side after all of that hard work is done. They say, does this situation represent direct variation? Well, again, a couple ways we know this. One, we have a K value of 9, right? We found our unit rate that was consistent for all of our points, which is great. But also we can look at our graph and see our graph is a straight line and it goes through 0, 0. So yes, this is direct variation. And then it says why or why not. Well, we know it's proportional because it has a consistent K value. Our graph is a straight line. And it goes through the origin, or 0, 0. Goes through 0, 0. Couple reasons that is direct variation, but 100% it is. All right, next one, they give us our table already filled out. We have to just answer a few questions. It says, what is the constant rate of change? So what is our K value? Remember, to find K when you're just given a set of points or a table of points, you use K equals Y over X. So I'm going to figure that out for each of these points, and the goal is to get a consistent K value, a constant rate of change for each of the points. So remember, 0, 0 just tells me that's my origin, so I'm not going to plug that in. But that is good news that we have that. For our second point, Y over X gives me 1 over 2, which can't be simplified, so my K value for that first point is 1/2. For my second point, I would do 3 over 6, which simplifies to 1/2. And then my third point here, I have 5 over 10, which also simplifies to 1/2. So we are good. We have a constant rate of change because all three of these have the same K value. So what is K? Well, K is going to be 1/2. Is this direct variation? Yes, it is. We know it's proportional. It goes through the origin. And we have a constant rate of change, which is our K. If yes, what is our equation? Remember, that's always y equals kx. So y equals, our K value was 1/2 x. All right, next one actually has 6 problems on it, but we need to figure out if each equation represents direct variation, a yes or no question. So kind of said this multiple times already. For it to be direct variation, your equation must be y equals kx. Remember, you always want your y to be by itself before you figure out if it represents direct variation or not. So looking at this first one, we have 5x equals y. My y is by itself. My 5 is my k. My x is there. This is absolutely direct variation. Looking at our second one here, we have 3y equals 9x. First thing I need to do before I can figure out if it's direct variation or not is get y all by itself. Right now, that 3y represents 3 times y. So I need to divide by 3 on both sides to get my y all by itself. When I do that, 9 divided by 3 is 3. Bring down my x. So y equals 3x. That is in perfect form for it to be yes, direct variation. Next one, same thing. My y is not by itself, so I need to get it by itself first. It's y plus 8, so in order to get rid of that 8, I'm going to subtract it. on both sides, which will leave me with y equals 4x minus 8. So this is going to be a no. It is not direct variation because of that minus 8. Remember, you can't have addition or subtraction added to your kx. That is not in the form that we need in order for it to go through the origin. So this is going to be a no. It is not direct variation because of that minus 8 there. Next one, we have y equals 2/5 x. Absolutely, your k value is 2/5, which is fine. That's in perfect order. And then the next one, we have y equals x. So remember that x, even though it's by itself, it has an invisible 1 in front of it, so my k value would just be 1. So this is absolutely yes, direct variation. Last but not least, 1/2 y equals x. Well, my y is not by itself, so I need to get it alone. 1/2 times y, so I need to divide by 1/2 on both sides. And I would be left with my y and my equal sign. Off to the side, I'm going to show a little work. I have x divided by 1/2. I like to treat it like fractions, so I'm going to make it 1x over 1. If you keep, change, flip, keep, change, flip. Keep 1x over 1, change it to multiplication, flip it to 2 over 1. You get 2x over 1, which is just 2x. And then when I look at that form, y equals 2x, that is in perfect form for it to be direct variation. So that is a yes as well. All right, next one. We have a scenario. We need to set up a proportion to solve it. It says Deborah can run 2 3/4 miles in half of an hour. How many miles per hour can she run? So start with your given rate, and we're going to put that on the left-hand side. So we have 2 3/4 miles, so mi, in half of an hour. Remember, time always has to go on the bottom. And then on the right-hand side, we're trying to figure out how many miles, so our question mark or our variable, in 1 hour. Multiple ways to solve a proportion. You can cross multiply then divide, or I can clearly see that if I take 1/2 and divide by 1/2, I'll get 1, and then whatever I do on the bottom, I can do the same thing on the top. So off to the side, I'm going to do 2 3/4 divided by 1/2. You do have access to a calculator, so if you would like to plug this in, that's totally fine. You would do 2.75 divided by 0.5 if you just want to show the work and write out your answer. First thing you would have to do is cartwheel to make this mixed number an improper fraction, which would give you 11 over 4, and then dividing it by 1/2. And from there, you could keep, change, flip. Again, you have access to a calculator, so you don't have to do this. If you typed it in, you will end up with the same answer I'm about to get. Keep 11 over 4, change it to multiplication, flip it to 2 over 1, multiply numerators, multiply denominators. 22 over 4 simplifies to 5 2/4, which can be simplified further to 5 1/2, which 5 1/2 with your units, miles, would be your final answer. If you did plug that in your calculator, it is absolutely okay if you put 5.5 miles. It represents 5 1/2 as well. All right, guys, go ahead and head back to your unit plan or agenda and click for part 2 of this video.